On this example, we're going to be looking at a cost function for a phone company. It's going to be dependent on the number of minutes that you actually talk. All right, so they've given us a formula, C of n, in this case, equals 17 plus 0.03n, where n is going to be the number of minutes, and then C of n is going to be our cost. All right, so that cost depends on the number of minutes that you talk. When we look at this function, what I'm going to do is go ahead and rearrange it. I'm going to think of this as C of n equals, I'm going to flip-flop our two terms, 0.03n plus 17. Now why I'm doing that is because I like to think about these as linear equations or linear functions, where we think y equals mx plus b. Now why I'm doing that is I'm thinking x is normally our variable. It's raised to the first power. Our real variable in this function is n. It's raised to the first power. What that tells us is this is linear when our variable is only raised to the first power. And most of these things, when we're looking at it, if you can break down the components, they all kind of mean the same thing. So in our case, if we wanted to pick out m, the slope of a line is equivalent to the rate of change. So in these application problems, a lot of times instead of thinking m as the slope, thinking m as the rate of change is very, very helpful. The other thing is b, normally we think of this as meaning the y-intercept. We can also think of this as meaning the initial value. All right, it's the value when our variable equals 0. All right, y-intercepts always goes 0, comma, some other y value, all right, to go with them. So in our case, all we have to do is basically line things up, and we'll know exactly what our rate of change is. Because our variable is n instead of being x, whatever number is out in front of that is going to be our slope, all right, or our rate of change. So in our case, our rate of change is going to be 0.03, and in our case, because our cost is in dollars, this is going to be $0.03 or 3 cents. All right, now the initial value, you could get that by filling in 0 for our number of minutes, so 0 for n, or you could just kind of compare things, line things up, and you can say, well, b, our y-intercept, our initial value corresponds with 17. Again, being that this is in dollars, it means it's $17 no matter how many minutes you actually talk. You're automatically going to get charged $17 per month, I guess, even if you talk 0 minutes on the phone. All right, hope this helps out as we line things up and try to understand how linear functions fit together with rate of change and initial value. Good luck.